amounts of fat, protein, and carbohydrates that we get from our food all help to provide our body with energy. And so this energy is given to us as calories. Now, the calories that we talk about in science have a lowercase c. The calories that are given on food labels have a capital C. And the capital C stands for 1 kilocalorie, or 1,000 of the lowercase c calories. And part of this is so that you feel better about the food that you eat. It's much easier to say you've had 80 calories than 80,000 calories. And so what a calorie is it's the amount of energy that it takes to heat up 1 kilogram or 1 liter of water 1 degree Celsius. And so the food calories, or the food, if we burned the food itself, we could measure and do measure the calories in that way by the amount of heat energy given off to increase the temperature of water. Now, please note that when we talk about the energy in our food, we are looking specifically at fat, proteins, and carbohydrates. There's lots of other things in your food, like vitamins, minerals, sodium. These do not contribute to calories or energy. So they do not give you calories or energy, but they are essential to your diet. So the combustion of our fats, proteins, and carbohydrates is what determines the amount of energy in our food. So when we look at the different types of molecules, so fats, they provide us with 9 calories for 1 gram of fat. If we have protein, it provides 4 calories for 1 gram of protein, and carbohydrates give us 4 calories for 1 gram of carbohydrates. So we refer to this as 9-4-4. Okay? 9 calories from fat, 4 from protein, and 4 from carbohydrates. So this relates to our nutritional labels. On our nutritional labels, the way that they determine the amount of calories is by looking at the amount of fat, the amount of carbohydrates, and the amount of proteins. So on this particular label, we have 17 grams of fat. So we can do a calculation where we take 17 times 9. That gives us 153 calories. We look at the amount of carbohydrates. We have 7 grams of carbohydrates at 4 calories per gram. That gives us 28 calories. And if we look at our protein, we have 5 grams of protein at 4 calories per gram, giving us 20. If we add up these calories, we come up with 201 calories. On our food label, it tells us that we would get 200 calories. So this does add up using this 9-4-4 rule. Calories tend to be rounded to the nearest 5 calories on food labels. One other thing to notice is that we are using the total grams of fat to do our calculation. And if we look at our saturated fat and our trans fat, it does not add up to 17 grams. So where is the other 14.5 grams of fat? What would that be labeled at, or how would that be classified? Well, it's not included on the label, but this is unsaturated fat. So it's not included on the label, but we can calculate it by taking the total fat, subtracting off the saturated and trans fats. So our body produces energy through a kind of combustion reaction. So we take the food molecules, we add oxygen to them, and we do produce carbon dioxide and water, and energy is given off. In our bodies, because we are not using fire in this case, in our bodies, these reactions are called respiration. So the oxygen comes from the oxygen that we breathe in, and our carbon dioxide is released through when we exhale. Balancing these is a little bit more tricky, but it is possible. The only tricky thing is that we have oxygen in our fuel source as well. So remember, we have oxygen in this particular example. This is glucose. And so because we have that oxygen, we have to take that into account when we're balancing our chemical reaction. Now, if we look at photosynthesis, photosynthesis is the opposite of respiration. So you'll notice our reaction is flipped. Now we're putting energy into the reaction through sunlight. The plants take carbon dioxide out of the atmosphere and water that is absorbed through its roots, and it produces our glucose and oxygen. So plants give off oxygen where we breathe in oxygen. They produce glucose where we burn glucose. So it's the exact opposite reaction. So it's the opposite of respiration. So hopefully throughout this chapter you've learned a little bit about functional groups and are able to recognize those functional groups in fats, proteins, and carbohydrates. You've discovered the difference between proteins and amino acids and what essential amino acids are. You can calculate the calories from the grams of fat, carbohydrates, and proteins in your food. And we've noticed the differences and similarities between combustion, respiration, and photosynthesis.